Hello everyone. Welcome to the YouTube channel Energy-Exergy Theory Applications. I am Tatiana Morosuk and I am the author of this YouTube channel. Today we are with the lecture on topic exergy. All lectures have a very dynamic style of presentation. Definitely some of you would like to learn more and discover the topic exergy more in detail. We will be happy to answer your questions and provide with the extended information. Our contact email you can find in the description of this video. And as usual, we would like to ask you to give a like to this video, maybe even in advance. Also subscribe the channel and share the link for this video with your colleagues. Today we're with the first lecture on exergy, and today we will discuss concept of exergy. Exergy analysis will be later. First, we need to understand what means the concept of exergy and why do we need this concept. Let us very briefly repeat what do we know up to now in the engineering thermodynamics. The first law of thermodynamics, it is principle of energy conservation. So I repeat that energy can be stored within a system, can be transformed from one form to another form, or can be transferred from one system to another system, or from the system to system sorting. And for the thermodynamics for evaluation, we have three kinds of system. We have closed system, we have open system, and we have so-called isolated system. Here will be not discussed because it is not the subject for energy engineering. And to define system, we always need to introduce system boundary. And open system means matter and energy can cross the system boundary. And for closed system, matter cannot cross the system boundary, and only energy can cross the system boundary. Based on the first law of thermodynamics, we can calculate, we can define the performance of the system. Mainly, of course, it is for the closed system. Open system for us associated only with the component, and closed system associated with the energy conversion system and different cycles we discussed it within the block engineering thermodynamics. So what means performance? Using other words, it is efficiency, and efficiency can be defined always as a positive effect over driving energy that we need to spend in order to generate this effect. So everything is only for the system, I repeat. And if we apply this equation, efficiency or performance, within this efficiency, there is no description of the working fluid that will be circulated within the system because matter is not allowed to cross the system boundary. We don't know which series of processes we have that matter will circulate through which series of the processes, and we have no indication if all these processes will be real or theoretical. So this maximum information that we can subtract from the first law of thermodynamics. And just to repeat that performance or efficiency, it is called energy efficiency, sometimes thermal efficiency for the direct thermodynamic cycles, and coefficient of performance for invert thermodynamic cycles, means for refrigeration machines or for heat pumps. The second law of thermodynamics, there is no one clear definition. We have set of sentences that are together form the second law of thermodynamics. And we are still with the closed system, with the energy conversion system. And based on the second law of thermodynamics, we know the conditions when this system will achieve the highest theoretical performance, means if system will realize Carnot cycle. And also we can find better operation condition, better to say operation conditions for the components, but not efficiency. This we should be very careful with the definition of efficiency. So if cycle is ideal, Carnot cycle, we can generate maximum work within this cycle, means that efficiency will be the highest. That if we have any of irreversibilities within the system, immediately the amount of work that we will produce will be lower and efficiency will drop. And the value of work that we cannot produce because we have irreversibilities, it is called lost work theorem or Gray-Stodella theorem, and can be calculated with the help of entropy generation. And the concept of entropy, of course, it is the second law of thermodynamics. And here we have the sum of entropy generation, means that we need to evaluate each irreversibility within the energy conversion system, or speaking about thermodynamic systems within the closed system. We have the list of classical irreversibilities. So within each component, we will have at least one kind of irreversibility, sometimes 2, 3, and can be even 4. And for one system, now I'm discussing about one energy conversion system, each component will distribute to the total irreversibility, and we can calculate total irreversibility within the system that will be described in the form of entropy generation, and we know how to calculate this value. So it means that irreversibility within the system, it is sum of irreversibilities within all components, or better even to say processes within the system. And of course, entropy generation can be only positive for real processes, or for ideal processes. When no irreversibility, then it will be 0. What is very important for us, that according to the definition of entropy, concept of irreversibilities, we cannot calculate performance. Second law efficiency that some authors are using such a term, it is wrong term. According to the second law of thermodynamics, we cannot calculate efficiency. We can calculate, for example, effectiveness of components, but effectiveness of components, it is not efficiency. Even if both can be discussed as a performance. Please remember that there is no second law efficiency. So, and already in the introduction to exergy in the video, we discussed that there are 4 questions that should be answered in order to evaluate of energy conversion system, and only 2 questions can be answered using the first law of thermodynamics and the second law of thermodynamics. 2 questions that cannot be answered using these 2 laws independently. It is performance of component, as a component is open thermodynamic system, and also we cannot compare performance of similar component when we discuss about different energy conversion systems. So, but we would like to answer all 4 questions using one concept. And we already mentioned that for this, we need exergy analysis. So now we are with the concept of exergy. Concept of exergy, we also will formulate using different definitions of exergy. All 4 definitions we have, all of them are correct, but we need to proceed from one to another to have a comprehensive view of the concept of exergy. The first statement, that energy balances only based on the quantity of energy. Energy in is equal energy out. But there is no possibility within energy balances to discuss about quality of energy. So from this moment, we always should discuss that energy has not only quantity, but also quality. Another question, and what means quality of energy? How can we define the quality of energy? Because if you will ask people who did not study engineering what means energy, people always assume that energy is, we can do everything with energy. What do we want, and what means quality of energy? All energy is with very high quality. No, this is not true in thermodynamics. And in thermodynamics, the definition of quality associated with the possibility to do something useful, or sometimes using the sentence cause a change. So how we can do something useful? It means that we need to produce work, because with work we can do a lot of useful stuff. So finally, the first statement about exergy, that exergy is the combination of quantity and quality of energy. So as each product, we have quantity and we have quality. Exergy can describe the of energy from the point of view quantity and quality. And since many people like very much GPT generated visualization in this YouTube channel, I continued with this approach, and I asked ChatGPT to generate the concept of energy. So how all forms of energy can be transformed from one form to another form. So here you can see all forms of energy together. But since we're discussing only engineering thermodynamics, and within engineering thermodynamics only macroscopic approach is used, definitely half of this picture will disappear because we will not discuss molecular level. And we can continue with this figure, and we can say that kinetic, potential, mechanical and electrical energy, so everything which is with macroscopic approach, can be fully converted to any other form of energy if we have ideal process. So one more time, at assumption that conversion process will be ideal, means without irreversibilities, these forms of energy, kinetic, potential, mechanical, and electric, can be fully converted to any other forms of energy. What about thermal and chemical energies? So it means that thermal and chemical energies also can be converted to other form of energy, but these forms of energy have quality. So thermal and chemical energy, they have quality. And quality depends on parameters. And as usual, for quality, we need reference conditions. So quality, we always should compare with some reference case. There is reference case, and after that, we can say quality is higher, quality is lower, quality is better, or quality is worse if we will use only linguistic meaning of the word quality. So here, one more time, for thermal and chemical energy, parameters, temperature, pressure, and chemical composition refer to the quality of these forms of energy. And in order to discuss the reference conditions, we should remember our concept of the system. Everything which is not included to this system, call it surrounding or natural environment. But we already mentioned that for some thermodynamic analysis, for evaluation, it's better to use the concept of thermodynamic environment. So to introduce the concept of thermodynamic environment, which in fact does not exist in the real life, it is only our imagination. It is just thermodynamic concept that can bring quite a lot of benefits for engineers. Remember the concept of entropy, we already used the thermodynamic environment. So thermodynamic environment, it is just a model, so something hypothetical which does not exist in real life. Thermodynamic environment should be as close as possible to natural environment, but nevertheless, it is not the same. And the thermodynamic environment always we should describe all these assumptions that we use for thermodynamic environment, temperature, pressure, and chemical composition, we need to describe. Another statement or definition of exergy, that exergy, it is the measure of the deviation of the state of the system from the state of thermodynamic environment. So to define quality, we need to discuss how far we are from thermodynamic environment. The more far we are from the thermodynamic environment, we can say the quality will be higher. So on this slide, you can see that quantity system 1 and system 2 are the same. So let's assume that quantity, it is the area of these clouds, but one cloud is further than, so cloud 2 is further than cloud 1 from thermodynamic environment. And according to the definition, system 2 will have higher exergy than system 1, but both systems will have the same energy. So one more time, energy, it is quantity and quality of energy, and exergy, it is measure of the deviation from the between the system and the thermodynamic environment. This is very important, thermodynamic environment. And few sentences, a few definitions for thermodynamic environment. First of all, since thermodynamic environment, it is something which is only exists in our mind. It is hypothetical. It is thermodynamic concept. Thermodynamic environment is free of irreversibilities. So never nothing can be happen from thermodynamic point of view. Within thermodynamic environment, there are no irreversibilities. And exergy of thermodynamic environment is equal 0 because it is our reference conditions. For reference conditions, it is like a thermodynamic 0. Therefore, very often all these characteristics associated with thermodynamic environment always have subscript 0. So reference state. And let us continue with the concept of exergy. Now we said that it is quantity and quality deviation from the environment, and let us proceed how we should calculate this value, because this is very important for us, not only theoretically to discuss concept, but also to give mathematical statements. So to do something useful, as I already mentioned, means to produce work. So for the concept of exergy, we always will discuss hypothetical engine. It is not heat engine, it is not internal combustion engine, it is just hypothetical engine, expansion machine, let's say like that. And when a system with the characteristics temperature, pressure, and chemical properties of the system will be expanded to the same characteristics for thermodynamic environment, so means temperature of the environment, pressure of the environment, and chemical conditions of thermodynamic environment, we can produce work as in engine. And this work, it is exergy. So means that exergy and work, it is the same. And all equations from thermodynamics that we know how to calculate work under different conditions, we can use all these equations to calculate exergy. So one more time, it is concept of hypothetical engine. No need to ask which process will take place, is a thermic, is a baric, is a choric, and so on. It is just hypothetical engine, where hypothetical expansion is taking place and hypothetical work will be produced. And the amount of this hypothetical work, it is exergy. So this is the concept of exergy. Now we will continue continuously to discuss exergy as work. So definition of exergy that always use it in all books, in research publications. So it is the comprehensive definition of exergy. Exergy, it is maximum theoretical useful work, maximum theoretical work that can be obtained from the energy conversion system at given condition if the system will be brought to the full equilibrium with thermodynamic environment. I repeat, full equilibrium with thermodynamic environment if system will interact only with this environment. Will be no other interactions with other systems and so on. So this is the definition of exergy. And I know publications where people say that concept of exergy cannot be applied for example, for refrigeration applications, because in refrigeration machines we are not producing exergy. This is not true, because definition of exergy has alternative definition related to the processes below of the environment. So exergy concept perfectly can be applied for refrigeration and for cryogenics. And what is the alternative definition? That exergy, it is minimum theoretical work that should be supplied in order to bring system that is with conditions below of the environment to the environmental conditions. So here work, maximum work can be produced, minimum work should be supplied. If you remember, this is exactly the definition of Carnot cycle. For ideal heat engine, maximum work; for ideal refrigeration machine, minimum work. So we are in full contact with the first and the second law of thermodynamics. So exergy has two definitions: for conditions higher than environment and for the conditions that are lower than environment. And We will continue with the simplest explanation that exergy is maximum theoretical work. Again, we have hypothetical engine, work is exergy, system in red color, let's assume that it is with temperature, pressure, and chemical composition, and thermodynamic environment with temperature, pressure, and chemical composition. One more time, I repeat, with subscript 0 means thermodynamic environment. And we need to bring system to full equilibrium with environment. Means that we need to discuss thermodynamic equilibrium, we need to discuss mechanical equilibrium, and we need to discuss chemical equilibrium. These three kinds of equilibrium we already discussed in engineering thermodynamics. In exergy concept, thermal equilibrium and mechanical equilibrium together call it physical equilibrium. So we have two equilibriums, physical and chemical, to discuss in exergy concept to produce work, or we can discuss thermal, mechanical, and chemical, like more detail. And again, I asked ChatGPT to generate visualization for the concept of exergy. This is very interesting. Immediately, I got such a nice figure where, so according to the majority of publications, definitions, how ChatGPT is working, immediately was visualization like that. We have thermodynamic environment, and everything which is above of the thermodynamic environment, immediately we can have exergy, or what is equivalent, maximum work, maximum theoretical work. Okay, it is just nice visualization. Let us continue with the theory. Few words about thermodynamic environment, because this is always difficult for the students and for young researchers to discuss about thermodynamic environment. And in some research publications, people just simply using the standard conditions for the thermodynamic environment. At present, it is temperature of the environment approximately 25 degrees Celsius and pressure approximately 1 bar, or in Kelvin scale, and in bars can be a little bit more precise, this value calculated. It is just standard values if you have no idea about environmental conditions where the system is supposed to operate in future and should be evaluated. So as before, exergy thermodynamic environment is 0 always, regardless of these conditions. It always will be 0, and we need to consider it 0, and of course free of irreversibilities. But if we would like that exergy analysis that we conduct will be more close to realistic conditions for the operation of system, definitely we need to consider the geographical location of energy conversion system, which the factor should be taken into account. First of all, average temperature overall the year in this geographical region. For example, if we're discussing about North Africa or south part of India, definitely this temperature will be not 25. Average temperature is much higher. And if we discuss about north part of Europe, for example, or even some regions in China, also temperature can be much lower than 25, can be plus 15, can be plus 10 average temperature. And then better to have really average temperature for this geographical region. And also, if we're discussing about area with mountains, also we need to keep in mind that pressure cannot be selected as 1 bar, because in mountains always pressure lower, depends on the elevation. So this is proper selection of temperature and pressure for the thermodynamic environment, as I mentioned, very close to real. That will make more sense to conduct exergy analysis for the system if you know exactly where the system is supposed to operate in the future. And let us continue with definition of thermodynamic environment. In exergy, we have possibility to select so-called restricted thermodynamic environment. What it means? That for thermodynamic environment, temperature T0, pressure P0, but chemical composition, so chemical description of the environment will be absolutely the same as chemical description of the system. This is again something artificial, of course, as a thermodynamic environment. It is, again and again, I will repeat, it is not real environment, it is thermodynamic concept. And since it is thermodynamic concept, we can also define chemical composition. And the case when thermodynamic environment have the same, has the same chemical composition as a system, but temperature and pressure are different, call it restricted thermodynamic environment, or state zero, call it restricted reference conditions. And for this restricted thermodynamic environment, there is a very complex definition. Now I will read this sentence. Usually it's very difficult to understand this sentence theoretically, but later we will have examples and you will understand that it is absolutely not difficult to follow. So for the restricted thermodynamic environment, intensive properties, temperature and pressure, assumed to be constant, but extensive properties, enthalpy, entropy, for example, can change as the result of interactions with other systems. The second part of this sentence, it is very much confusing, but as I told you, at present, just assume or trust me that this sentence is correct, and within next lecture, I will give you proper definition and confirmation of this sentence. And at the end of our lecture, I would like to already announce that lecture 2 will be dedicated to components of exergy. So means we will continue with the concept of exergy. And if you found this lecture interesting, useful, please give like to this video, please subscribe to channel and share the link with your colleagues. Thank you.